I'm going to draw a small graph with a few cities. These are going to be the abbreviations I use for the cities. And so I'm going to use these distances, or just these labels for the edges. And I need to graph this, so I'm going to plot. So I'm using here already some variables, some options here that are not default. Edge labels, we want the labels to be there. Figure size, so this is something that we can play with to have the total size of the figure. Layout, I'm going to use the circular one, is going to put the nodes in a circular way. And vertex shape, I'm going to put a square. We can put also other shapes. And the vertex size, I'm going to put this one. So let's see what happens with these choices. So we see already this look like too big to look at it, but you see that the squares shape of the nodes and also the size allows for the whole name of the city to be in there. But this looks too big for seeing this screen. I'm going to do this window small. I can put 8 and will be like a rectangle, right? And so still it's a little big. So I'm going to put it like 5, a square window here, and I'm going to run. That looks better. Maybe we can keep playing about the vertex size and the figure size, but so we have an idea now how it looks like. So now, if you put a Hamiltonian cycle, so let's see what happened here when we try to find the Hamiltonian one. So we run it, and it says it's true in Hamiltonian. It's possible to find a Hamiltonian cycle, and it's this one: Athens, Chicago, Havana, Paris, Rome. So it's giving this one here. Clearly, looking at the numbers here, this is not going to be the shortest one, because we are not asking for the shortest one. We are asking for the Hamiltonian. So we are asking simple for a cycle that travels all the cities. This is one, this is good. So now if we want the shortest one, we have some choices here. We can do, for instance, shortest path. But then we need to calculate the shortest path, we need to put the shortest path between what and what. So for instance, between Chicago and Havana, what would be the shortest path? Well, let's also find the length of that one. So from Chicago to Havana, right? So I'm going to run it, and here it is. The path is Chicago, Athens, Havana. So Chicago, Athens, Havana, and you see that is 4 and 1 is 5. So this is what is given for the second command. It's 5 the distance. But you see that the direct one between Chicago and Havana in this case was longer, right? So this is really the shortest path. Well, we could try to do this for a circle, but we have a problem here, because we can try to do the same, but instead of Chicago, Havana, let's put Chicago, Chicago to get going back to Chicago. So what is going to happen here with the shortest path? Let's run it. Oh, the shortest path is 0, right? So to go from Chicago to Chicago, definitely the shortest path is to stay where we are. So that's what this is giving us. So you know that the shortest of the Hamiltonians is going to be given by the traveling salesman problem. So that is the command that we're going to use. So I'm going to put G, which is the graph that is here, and so traveling salesman problem. So we want to put maxima as false. We want the one that is a minimal weight, not a maximum. And so, but this is creating a new graph, H. And so if we want to actually see the graph, I mean, the path that we should do through all these cities, we should plot it. So then I'm going just to copy the same scene there before, but with H plot, and the figure size, we have put, which one was 5.5, let's put it here, 5.5, the figure size, and let's get rid of this other option just to make it exactly as it was before. We should copy and paste this. Let me just copy and paste to make it easy. I'm going to copy and paste this here, but I wanted to do it with a new one that is H. Okay, so this is the one that I want to see. I want to visualize what is the path that is optimal, but also I want to know how long is it, so I want to ask Sage to print the addition actually of all these edges. Let's run it, and here it is. So you have the way to go from Chicago will be to go first to Rome, then to Athens, then to Havana, then to Paris, and then to Chicago. And the weight of the whole path is 20. If you want to have this drawing exactly on top of this one, you can do that also. Just check the videos.